everyone. Thanks for joining my talk. I am Joymallya Chakraborty. I am a computer science PhD student at North Carolina State University. My advisor is Dr. Menzies. This is the link you can follow for this talk. Here I am going to talk about my NIER paper, Making Fair ML Software Using Trustworthy Explanation. This is the brief overview of my talk. First, I will talk about ML software discrimination. Then I will present how to find the bias or discrimination using instance-based explanation. There are two common approaches, LIME and SHAP. Then I will describe their shortcomings. Then comes the fair KNN, which is my method to overcome those shortcomings. I will show some preliminary results. Then I will talk about my future plannings. Then I will conclude and I will be open for questions. So what is ML software discrimination? Nowadays, almost every software uses some kind of machine learning model. If a software uses machine learning model, it is called ML software. Now, in some cases, we see that machine learning model shows some kind of bias based on some sensitive attributes like gender or race. Let's look some examples. The first one is Google Translate. Suppose we are translating from English to Turkish and the sentence is, he is a nurse, she is an engineer. We convert it to Turkish. Then we again do the reverse. That means from Turkish to English, it becomes, she is a nurse, he is an engineer. So this is a gender bias. The second thing we have seen that a lady with dark skin color is trying to recognize her face using a face recognition algorithm, but she's not being able. When she's putting a white mask on her face, then the algorithm is detecting her face. So here we are seeing racial bias. The third is a loan program where there are 4 features: income, savings, age, and race, and a model is approving or denying the application. If it is based on savings, it is fair, but if it is based on race, it's not fair. Now, how to detect this kind of bias? There are certain bias metrics to find bias in a machine learning model, but they have their own shortcomings. So nowadays, people have been using SHAP and LIME explanation algorithms. So what is SHAP? It is an instance-based explanation algorithm. Suppose a machine learning model is giving you the mortality rate, which is from 0 to 1. And here we are showing one example where there are 4 features: age, sex, BP, and BMI. When we are using SHAP explanation, we see which features are important and how much. Suppose in this chart, we see that most important feature is age and then sex. And from this explanation, we can say if the model outcome depends on specific sensitive attributes like sex here, that means it may not be ethical. There could be any kind of bias. The second example is LIME, which stands for Local Interpretable Model Agnostic Explanation. This is also an instance-based explanation algorithm. Suppose we are explaining one data point, that is the big red cross. What LIME does, LIME samples around that data point. So the other red and blue dots are here other samples generated by LIME, and then checks the model output for those data points. Depending on that output, LIME creates a linear model or linear equation, that is the dashed line. So from the linear equation, we can get the feature weights or feature importance. So for a specific data point, LIME can explain which features are important for that particular outcome of that data point. So these two methods are being used to find bias in a particular instance by a machine learning model. But are they trustworthy? No, they are not. A recent study, which was done by Slack and other researchers, found out that LIME and SHAP explanations are not trustworthy because the way they generate samples, most of the time, the samples are not representative of actual training data. Here in the photo, we can see that the blue dots are basically the actual training data and the red dots are generated by LIME sampling. So you can see that they are not the same. So if your explanation is based on those red dots, the explanation cannot be trustworthy. So here comes our proposed method, that is nearest neighbor, k-nearest neighbor, and we call it fair because it is used for fair classification. We actually sample from the training data. we don't generate samples. We have explored our approach in adult census income dataset, where the target class is high income or low income. It's a binary classification dataset, and there are two sensitive attributes, sex and race. So for any test data point, if the model predicts negative outcome, then we find k nearest neighbor data points with opposite class levels from the training data, and then we see the data distribution of those points. If we find the difference is only in the sensitive attributes, here gender and race, then we say this data point is unfairly predicted and we raise an alarm. Let's look at one example. So here in the table, the last row is the test data point, where the value for sex and race is black and female respectively. And other 5 data points are from the training data, where class level is positive. But for the last row, model our model logistic regression model is predicting negative outcome. But when we see the data distribution, we see the major difference is the value of sex and race. So this data point is being said a negative outcome just because of the value of race and sex. So this is unfair treatment for our model. So that by this way we can find, using fair KNN method, whether a particular data point is being treated unfair way or not. And this is more trustworthy than Lime and Shap, because we have already said that Lime and Shap generate samples randomly. They are not representative of actual training data. Here for the same data point, we use Lime and Shap. The above picture is for Lime explanation, and the below picture is for Shap explanation. If you see the feature importance, you see that Lime and Shap both are not complaining about gender or race. So this is not trustworthy. So we find our explanation is better than Lime and Shap. Now, in the conclusion, we have a future plan to show, because this is a very NIR paper. This is only preliminary work has been done. Our future work is not just doing singular instance-based explanation, but also to repeat it for all the test data points and summarize this so an organization can create policies. By that way, we can combine fairness, explanation, and planning. And also for doing, we have a plan to do hyperparameter optimization, because here we are using Euclidean distance metrics. We can go for Manhattan in cascade-based distance metrics. Here we are giving every feature equal importance, but we can go for custom Euclidean distance measure, and this paper is based on individual fairness, but if we repeat it for group wise, like male and female wise, then it will be applicable for group fairness too. So these are our future work. Now I am open for questions. Thank you for attending my talk.